I will talk about the how to create the base template for the base template solver in OpenFOAM. I hope and basically I will create the from the scratch. If we are not taking any copy and paste here, whatever we are making a solver from the scratch. Now how we can make the solver in scratch? So here today I will talk about the there is some command so we can create the template for the solver, which and solver basically what we are going to make based on our requirement. Suppose we have the specific information, so we want to solve some equations, so that that equation we can write those equations in the standard format of the OpenFOAM, which we can include into our solver. Nothing else we have to change change in the solver thing. If you are creating solver from this manner. So now let's talk about the let's start and see. So now just first we have to actually in my machine there is so many there are various OpenFOAM version is installed. So now I can take any one of them, but now I'm just taking OpenFOAM version 8. Yes, now let's see. Now just one second. Now see, let's we can execute run. Basically this how run is work I explained in the previous videos in very detailed manner. So either we can just execute, we can run, just we can execute run, just cd, just go, we can cd, just we can go to the home, just home. Basically we can visualize the path, it will display the path. So basically we are in home. How we can see, check the home, just we can see one more way. Just home, type just home, cd home, just cd home, we are in home now. Now suppose we want to go just execute run this. There is a one way, another way is just go to the home, and another way is just cd, just just dollar foam and foam underscore run. This is the this is the environmental variable which we have set here. So we can see there's the two way we can go to the run directory now. So run directory. Now suppose we want to make some solver here, like we can demonstrate we can demonstrate how we can create the template base template of the solver. So now there is a one utility here, there is a one command. So I will explain how we can create. Suppose we can create we can give any path where we want to create the solver. So basically like just make and directly solver. Okay, just solver, just enter ls. So we can go into the solver dictionary, solver. Yes, now we can visualize the path. Yes, this is the behind solver. Now we here in this directory we can create a one template of the solver in solver. So now which command we have to execute here? Foam, foam, foam new app. So now you can give the name of which you want to go to or is basically desired solver. You can specify this solver name is user specified. It depends upon user which is a user has a freedom. We can yes. Now suppose new solver, I'm giving the new solver form. This is the new solver form I'm giving this thing. Now just enter. Now new, oh there is a mistake, form mistake, FOAM, there is a spelling mistake here. Now Yes, have a look inside the ls. Yes, as you can see, there is some directories created here. Directory is created, name is new solver form. Let's see ls minus la. So there is nothing here, nothing, only this the directory new solver form. So let's go into that new into it. That let's visualize this thing. Now see the in this directory basically which we have given the name of solver, this new solver form. So there is a there is some there is some directory and files. Now if you want to see the which one is directory and how many directory and files is there, then you can just type 3 minus l into 2. So it will display here how many how many files and dictionary into this dictionary, this directory. So let's see, there is a two, one is directory here and one file. There is a one another in file in this directory there is some files also is there, two files and this. Now this will it will give the statics of the dictionary, how many files and directory inside associated with this directory. So see, let's see, there is a see now basically here how there is a various way to visualize. One is this, another is this, and there is a this, and there are so many things. And if you want to see, if you want to see in the directory, in this directory how many files you can see, just ls star this one star and this, you can see this the make directory, and it directly is considered the files and options. Two file is considered two files here. Like I basically best representation of to visualize this dictionary directory statics. So that is the good way. This is the best way which I prefer to visualize the how many files and this. And there is a like one level also you can visualize. It will show the one directory, one file. Yes, if you see, if you can put three level. So there is a three level basically here to directory, three file, three level is not there because make directory doesn't have any dictionary directory inside inside the make directory. So that is a basically visualize this. Now let's see, just clear the screen. No, this is no clear. Yes, now this one. Now see what is inside the this folder, this solver name and this directory. Just first I will visualize this one and solver which we are created, and what is inside this. I will use this BI editor. You are free, you can use any editor which you are compatible. Is up depend upon user. Now see, let's see inside this file. So as you can see that basically that the standard format of the solver in the OpenFOAM is created. Now have a look. See, so see here basically include this is included. Yes, and basically this is the basic structure of the solver is created. If you want to solve the other equation, just you have to include here. You can look at you can look any solver for your just to get some information. Then based on that you can include like you can include the equation. Just you need to do some you need to understand some physics, and you have to structure accordingly. So that is the basic this one basic solver template is created. Now I'm just going to exit this one. This one, no. Yes, now have a look inside the this make directory. What is inside the make directory? ls, just you can see vi file. See you can see the vi file. Generally what we do, just there is some two way to create the solver. Just we can copy the solver from the base base solver source code, and you can modify based on this, and after that you need to modify this user here. User basically that we have to specify the path, executive path basically here. Now like here is by default is created user, so we don't require to change this this path, this environmental variable here. So no, we don't require any change here. Now have a look in the option. Yeah, option. Yes, you can see the executor inside, the executor included library. Library is this finite volume. Basically these the library, basically src, which is included, which it mean that that is the source code. It's we are including, we are using some files which is already in source code, so that's what we are including here. We don't require, we don't require to use or add anything. If you are copying some from some yes, and the library also by default is created here, so that is the standard thing. So just we can exit out, and now let's see, and we can edit cd. We can go one level back. So now we are in the solver directory. Now what we do, just now we have to build the solver. What we need to do the build a solver, just we make w make, we have to execute it, this one. Yeah, and now you can see this solver is successfully is built. You can see we couldn't get any error. If you want to see where is this solver, basically this one, like I said, run here is here at this path. Basically this path, there is some platform, basically all the executable, then it will go and it will save in the bin here, because this the user is specified. Now like we have the we gave this name of this to the solver is this new solver is created here. You can see and you can visualize. Yeah, now if you want to, now suppose this solver is build. Now suppose if you want to use cd, just like now I'm in home. Now just if you don't know, then you can just type home. Yes, ls. Yes, now there is a two way. One I said this one, otherwise you can use the build server. Now we want to solve this, now we want to test is working or not. Just you can type the solver name, new solver, this new solver which we have created, just execute here. So the is successfully is build this solver. So because it is this error, because we are not given anything, just we have not created any case and something. That's what is generally this the nothing. So this base template of any solver is created successfully. Now what if you want, and basically if you want, and generally what people do, just copy, and people they copy from the source code from the OpenFOAM, then and copy to the desired location, and just add it, and add it based on their requirement. So here just now what is the use here, here everything is set up. Now what you have to do, just go to the solver and just edit the standard format equations into your folder, into your solver, where cd solver, let me see where is this cd solver ls cd new. Yes, this one here, the solver. Now what you have to do, just the basically standard in any standard format you will get this this two file, some another file also, two, one directory and two file you will get. Generally you will get another file that is the same name, but that is the extension is the header file. Basically that header file it include all the create variables, creates variable. You can create the variable and yes. So then basically that is a standard format. Now if you want to see let me show one case here, case to you, and see like be new, this one, have the basically this is the basic standard structure of the solver. Now just have a look the some for example some case base case. So let me go exit here and just cd just I'm going to back. Now see, have a look. So if you put the sol, if you use the sol, just because that is the already environmental variable are set, so it will take you the source code where is OpenFOAM installed and all solver are there. See, have a look what is inside the solver in this solver directory. So basically contain all the by default solver which OpenFOAM contains. Yeah, it's c3 minus l is 2. Yes, you can see, or you can see one level only. So see, there is a this solver directory, it contains these are the solvers, basic solver combination compatible, and have a look some basic solver. Just we can go into the cd incompressible and see, and see how many solver has contained is solver is these some these this one to these solvers. So have a look the simple form. Just we can go into the simple form, cd simple form ls. Just have a just we can do this. So basically simple form is contain four files and three directory. Basically that is the include directory. This you can so then just that's purpose there is just two equations here. So one equation pressure equation and momentum equation here. So just basically this is solver, and I said na, create variables. Basically it contain all the variable which defined so which we are calling into the solver. So have a look inside the solver bi simple form, this one. So basically that is the structure of the solver as I showed you, whatever like here but here we have we are going to solve these two equations here. So that's what we are including. Some file header file also we are including here which already defined the source codes. Yes, now this is the basically standard. Just I'm going to exit here ls. Let me show you that this what is inside the this one make cd make this make there are two files. One is files and another vi and files. What is that? Basically just you can see the difference here. Now if you want to there is a two like earlier I said there is a two way. Just we can copy this solver to the another location and modified it. So then you have to create the then you have to add the user. Basically that user is that you have to specify the path. Yes, here, but here no, because this is the already in the source code the OpenFOAM. Yes, so that is the difference here. Now exiting. Now you can see the b option file also. So there is some like generally we have two options, one finite two library included which is in the src. These are two by default. If you create this, basically these libraries depend upon you. If you are these files, basically these files it depend upon your problem, which problem you are going to solve. So you have to include it here, or if not there then you have to create it in your own here, and you have to give the path here in the similar fashion, and you similar way you have to give the library path also. Yes, there is a now just I'm putting here less basic. Yes, now cd yeah ls. Now this is the simple way. I just I'm going to exit here. Now I'm going to the same cd solver new cd new solver. Yes, ls and bi new. Yes, see because here we have not considered any equation. So that's what this is the basic template is created. so we can modify it and we can add the equation which we are going to solve. Yeah, no, that's it. That's it. This is a very good I feel this is a very good command, so we can create the template and we can modify it based on our solve, our desired solve which we are going to create it. So now that's it for this. Now if you want to, basically I will cover the basic this tutorial, all the demonstration for the only the beginner, because I got many requests and people ask, some student ask that please sir, if you have some material though you can share it. But as we know that we don't have the standard documentation for this open form. Yeah, so we are creating we try to uh, we try to create and understand the how this is small commands, and you can learn. I will cover most of the command, most of the utility, you can say utilities, like we have the like another utility like for the mass creation, like we have to very powerful to very but if you have the in-depth knowledge, then it's very good to use that mesh tool, where you can use that utility to create the good quality mesh. Also there is a snappy hex mesh which is a very most powerful tool. And another, if you have simple geometry, then you can use the block mesh, the block mesh utility. Yes, there is a two utility. So we can the purpose of this demonstration will be I'll create if people ask me, I'll create a one by one a small all, and I explain all the command house work. But keep in mind we will not go to the advanced level here, because this purpose to demonstrate the only for the beginners, which most of the student they want to learn this open form. We do yes. But if you want to the more in advanced level, then we have the another thing. So I am planning to create the for the forum for the advanced level. But this is the purpose of demonstrate the whole uh, uh, it will cover the basically way all the basic fundamental, so then people can get, and they can start using open form. Yeah. And if you like this these demonstrations, that you can comment, you can comment on if you want to if you want to the most if you want to more explanation and more demonstration for other utilities, other commands, so I will prepare for that. But I will not cover many things at a time. I will cover only the single thing in at a time. Please keep you can give your you can give the your feedback. You can comment which you want to like more to demonstrate, so I can cover it. And so you can subscribe and you can share with your friends, so we can connect with the more more students or more beginner who want to learn this open form. As you know, the open form is basically open source and is free to use. And but only one thing you have to learn, and you have to learn, and you can explore things yourself, and people can help you, but nobody are going to solve your problem. If you like what recently I had some experience, so people ask me about they share their problem and they want to do, I have to solve. No, but I can't solve, but I will help you if you start. Then if you stuck somewhere though, then I help you to uh, for that. But yeah, it's fine. No, yes, no, thank you for watching. No, yeah.